Hey guys, it's Mrs. Conway. Sorry you can't see my face, but with the graphs, I think it's a lot better for me to use the document camera rather than to try and do this on Teams. So I'm going to work this worksheet out on my document camera. So I'm going to recommend to you that you print this out if you can. You might also want to find yourself a ruler to use for this worksheet. All right, so first things first. We're going to move into a new unit now, which should have some familiar and some unfamiliar things. So the familiar part is we're going to be graphing lines. So that should be familiar. And then inequalities should also be familiar, but what you haven't done is inequalities in two variables. So that's what a linear inequality is. It's a two variable inequality with a line. So it's two variable. So essentially what we're going to end up doing here is we're going to draw a line, and we're going to shade either above the line or below the line. So the solution to a linear inequality is the set of points that satisfy the linear inequality. And effectively it's going to be a half plane. It's going to look like half of a graph is shaded. So I'm going to say it's the set of points that satisfy the inequality. And so it's going to either be above or below. Now sometimes we include the line and sometimes we don't. That has to do with whether there's a line underneath our inequality. But let's first just take a look at how this works out mathematically. So when you have a system, when you have a linear inequality, that means that you have something like 2x minus 3y is less than 15. Okay, so the sort of thing to think about before we start trying to actually solve this is what kind of points make this true. So remember, when you have a point like 2, 5, 2 is x and 5 is y. So I'm going to take my inequality and I'm going to replace x with 2 and y with 5. So 2 times 2 minus 3 times 5. And see, is that less than 15? So here I'm going to have 4 minus 15, which is negative 9. Is that less than 15? Yes. So this is a yes. I'm going to zoom that in just a little bit. Hopefully you can see better. It does show better on the computer screen than it does on the projector. Then here we have 2 times negative 1 minus 3 times negative 7. Is that less than 15? That's negative 2 plus 21, which is 19, which is not less than 15. 19 is greater than 15, so this does not work. Okay? So basically all we're doing here is do these points work in the inequality? And this is a way to sort of see what kind of points do work in this problem. So then let's see, we have 3, negative 4, 2, negative 4, that's 6, sorry, plus 12, which is 18, is not less than 15. That's not true. So this one also doesn't work. Okay, and then the last one, 0, 0. 2 times 0 minus 3 times 0. Is that less than 15? Well, that's 0, which is less than 15. So the last one works. So we're going to use these when we move down here, because you notice our first example is 2x minus 3y is less than 15. But now you can kind of get to an idea. So this point works, negative 1 says negative 7 doesn't, 3, negative 4 doesn't, but 0, 0 does. So kind of like the first quadrant does work. So we'll look at that when we see the graph. But first let's sort of talk about how we do this. So if you want to graph an inequality, first of all it has to be in slope-intercept form. Just like any other equation. And this is the really important part. Be sure to flip the inequality symbol if you multiply or divide by a negative number. That still holds. We talked about that in the entry tasks. And we've done these, but if you divide by a negative, you have to flip that inequality. Okay, so when you graph the line here, there's one thing that kind of comes up different, especially if you're not using a pencil. you're not always going to make a solid line with these. Sometimes you're going to make a dashed line. And when I say dashed line, I mean like dashes on the road. So your line will look like that, or it'll look like that. Okay? And then that goes for greater than or less than. You use a solid line for greater than or equal to or less than or equal to. So then when I say solid, I mean just like a normal line. Okay? And then shading. Now you can test points to check and make sure you shaded the right region, but you can also just use the inequality symbols to help you figure out which way to shade. You can shade above the line when it's greater than or equal to, as long as it's greater than. All that changes between greater and greater than or equal to is whether you make a dashed or solid line. So, you know, depending on how your line is facing, and I'll use a dashed and a solid example, above looks different. For a negative slope, above looks like this. For a positive slope, above is like this. When I say above, I'm thinking like if this was a hill, if my line was a hill, above it would be where the air is. And then below is for less than and less than or equal to. And same thing. Below now is where the ground would be if this was a hill. So, for example, 2x minus 3y is less than or 15. First, have to put it in slope-intercept form. Minus 2x on both sides. With negative 3y is less than negative 2x plus 15. Same steps you would use if this was an equation. Except, now I have to divide by negative 3 on everything. That's still the same step, but what happens now is because that was a negative, I need to make that a greater than. Flipped the sign because I divided by a negative, sorry. So right here, I went from less to greater because I divided by a negative. So now I just have to do this math. That's positive 2 over 3x minus 5. So this is the line that I graph. And then this is a dashed line, and it's greater than, so I'm shading above. So starts at negative 5, and then I go up 2 over 3, okay? Now I'm making a dashed line, which I have to know that before I draw my line, so I make the right kind of line. So dashed means I pick up my pencil as I draw the line. See how my line has gaps in it? And then I'm shading above it, but I'm just going to check 2, 5 is right here. I knew that worked. Negative 1, negative 7 would be down here. I knew that didn't work. So far, so good. 3, negative 4. I know that did not work. So I don't shade on the side of those points. And 0, 0, that one should work. So notice I'm shading where the points that worked are. So my final answer is any point above the line here. You can imagine any point that's above the line would work for the inequality. So you're essentially trying to plot all of those points, but that would be impractical. It would take forever. So you're shading it to indicate that, oh yeah, I would plot all those points. So it should be solidly shaded in. I know I'm using a pen, so it's not perfect. But as long as you can get the general idea, we're good. So that's how we graph a linear inequality. So our final answer should be a line that's shaded above or below, and the line itself should either be dashed or solid. And the reason this one's dashed is because there's no line under here. It's like, I own this property, but I don't own the fence, so the line is dashed. Okay, let's do just a couple more. And then you can go work on practicing on delta. So here we have y is greater than 1/3 x minus 5. So this does not need to be solved because it's already in slope-intercept form. So hopefully You might just need to look on the back, but see that this is greater than, so it's going to be a dashed line, and it's going to shade up, okay? So starts at -5, 1 over 3. And I'm going to do just a couple to make sure my line is nice and straight. And don't forget, this is the part where you have to remember to make it dashed. Of course, on Delta Math, all you have to do is select the dashed option. But okay, and then it says above. And then if you just want to check really quick, like 0, 0 is above the line, so it should work. Is 0 bigger than 0 minus 5? 0 is greater than -5, so it works. So I'm going to shade above the line, like that. All right, try number 2 by yourself. Ready, set, hit pause. So hopefully when you graph number 2, you got a graph that looks like this. So then hopefully you should be able to do this. So what I'm going to do is I'm just going to have you hit pause, try out the rest of these if you want, and then otherwise go work on your Delta Math. But I'm going to go ahead and finish the rest of these so you can see what the answers look like in case you want to try them out by hand, because some of this is a little easier to just do by hand. All right, hopefully you've had a chance to try out numbers 3, 4, 5, and 6. So just take a quick peek and see if you did them correctly. So for 3, you should solve and get y is less than 5/2 x minus 6. It's a dashed line. You shade below. 4, it's when you solve it, you end up with y is greater than 1/4 x minus 2. Shade above, dashed line. Number 5, I had to flip the sign again. Y is less than x minus 8. This time it's a solid line because it's got the line underneath it. And I shaded below because I had to flip the inequality. Now, this one probably felt funny because for one thing, you didn't have to flip the inequality because you divided by a +2, so it stayed less than. And then the y-intercept is 0, so you might have left this +0 here. But realistically, you don't need to, but it does start at 0, 0, and then goes down 3 over 2, dashed line, shade below. Okay, and then the last two were definitely kind of weird, but good things to practice. Y is less than or equal to -4. Remember, when it's y by itself, that means your slope is 0, so it starts at -4, and it's just flat line, and then it's solid and above. That one's not so bad. This one's the hard one because the same rules don't apply. Because there's no y, it's an undefined slope. But then you can't shade up or down, so you have to think left or right, kind of like you would with a single variable inequality. So you go to the right because it's greater than, so it would be over here. So now you should go ahead and practice some of these on Delta Math. Good luck.